By the end of this video, you'll be able to write a real bash script, one that runs, stores data safely, makes decisions, repeats work, and organizes logic into reusable functions. We're covering 5 Level 1 lessons from the Shell Mastery Path, in the order they build on each other. Every bash script starts the same way, a shebang line telling the OS which interpreter to use, then permission to execute it. Let's write one from scratch. Before scripts, get comfortable with these 4. pwd shows where you are, ls-la lists everything including hidden files, and cd moves you around cd.d, always goes up exactly 1 level. The shebang has to be the very first line, no blank line above it. It tells the operating system to find bash on your path and run this file with it, which keeps the script portable across machines where bash lives in a different spot. Before you can run it directly, mark it executable with chmod +x. Once the permission bit is set, running it with a / prefix executes it right there in the current directory. Read -r pulls in a line of input from the user and stores it in a variable. The -r stops backslashes in what they type from being treated as escape characters, which is almost always what you want. That's a working script that takes input. Next, let's talk about the variables it just used and the quoting habit that saves you from some of Bash's nastiest bugs. Bash variables are simple on the surface, but a few rules trip up almost everyone starting with the fact there's no space allowed around the equals sign. Assign a variable by writing its name and equals sign, and the value, with 0 spaces on either side. Bash actually tries to run a command named after whatever's on the left if you add a space there. Reading a variable without quotes lets Bash word split it on spaces, which can silently turn one value into several arguments. Wrapping it in double quotes keeps it as one piece. This is the single most important habit in the whole curriculum. Arithmetic happens inside double parentheses. Bash has no native decimal type, so division here truncates to a whole number. If you actually need decimals, you reach for a tool like awk or bc instead. Marking a variable read-only locks its value for the rest of the script. Any attempt to reassign it fails loudly. Unset does the opposite, removing a variable entirely, which is different from just setting it to an empty string. Parameter expansion gives you defaults for free : means use this fallback value only if the variable is unset or empty, without needing a whole if statement to check first. Export marks a variable so it gets copied into the environment of any child process the shell starts. A plain variable stays local to the current shell and won't be visible to scripts or programs it launches. With safe, quoted variables in hand, the next question is, how do you make decisions based on their values? That's control flow. Bash's if statements don't check true or false the way most languages do. They check whether a command exited successfully, which changes how you read every conditional you'll ever write. Double square brackets are Bash's safer, extended test. It runs as a command that exits 0 for true or 1 for false, and if runs the next block only when that exit code is 0. Bash groups its comparisons into 3 buckets here: string equality, numeric comparisons that use words like -lt instead of a less than sign, and file tests like -f and -d that check the file system directly, all inside that same double bracket syntax. Inside double brackets, and or work directly, so you can combine multiple conditions in one if statement instead of nesting them here. Both the age check and the ID check have to pass. For pure number comparisons, double parentheses read more like a normal programming language. No dashes needed, just greater than and % for modulo, which makes arithmetic-heavy conditions easier to read at a glance. Case is Bash's pattern matching switch, much cleaner than a long chain of elif when you're checking one value against several options, and the pipe character lets you group multiple patterns onto a single branch. Now your script can make decisions. The next piece is doing something more than once loops. Bash gives you 3 loop styles, and the idiomatic pattern for reading a file line by line is one every shell script eventually needs. A for loop over a plain list runs its body once per item. Swap that list for a glob pattern like star.txt, and it iterates over matching file names instead. When you need a numeric counter instead of iterating over a list, the C-style for loop gives you the initializer, condition, and increment all in one line, just like in C or Java. This while-read pattern is the safe way to process a file line by line. Setting ifs to empty keeps leading and trailing whitespace intact, and read dash or stops backslashes from being treated as escapes. Until is the mirror image of while it keeps looping while its condition stays false, and stops the moment that condition finally becomes true. Same job as while, just read the other way around. Break exits the loop entirely the moment its condition is met, while continue, which we don't show here, just skips ahead to the next iteration without stopping the whole loop. You can now repeat work and bail out early when needed. The last piece for today is packaging all of this into reusable functions. Functions in Bash take arguments the same way scripts do as numbered positional parameters, and a couple of habits here will save you from some genuinely confusing bugs later. Defining a function is just a name followed by parentheses and a block in curly braces. Inside, $1 refers to the first argument passed at the call site, exactly like a script reads its own arguments. Quoted $@ expands to each argument as its own separate word, which preserves an argument like hello world as a single item instead of splitting it apart. Always prefer this quoted form when forwarding arguments. Return only sets a numeric exit status between 0 and 255. It can't hand back a string or computed number. To actually return a value, a function echoes it, and the caller captures that output with command substitution. You can combine that :_ default trick from module 2 right inside a function's parameter list, so callers can skip optional arguments and still get sensible behavior instead of an empty string. Without the local keyword, a variable assigned inside a function is global by default, a common source of bugs in longer scripts. Declaring it local scopes it to that function only, leaving the outer variable completely untouched. That covers the core building blocks: script setup, variables, decisions, loops, and functions. Module 10 in the source material combines every single one of these into one real backup script. That's a complete script vocabulary: setup, variables, control flow, loops, and functions. Everything level 1 builds toward before Module 10's backup script project ties it all together. Every lesson we covered today is linked below if you want to read the full text and try the exercises yourself.